Okay, part D. He says, this is g of x, find g minus 1 of x. Let's do it. Okay, the first thing we do, guys, is we swap x and y. So if this was y equals this, we say x equals arc sine y squared plus, or y squared minus 1 over y squared plus 1. So swap them straight away. And then we rearrange to make y the subject. So to get rid of arc sine, we say sine x equals y squared minus 1 over y squared plus 1. We need to get these y squareds on their own. So we do y squared sine x plus sine x. So that's just multiplying this by sine x equals y squared minus 1. Subtract that y squared here. Subtract the sine x here. Take out the y squared, sine x minus 1. This is the same. And then we divide by sine x minus 1. I'll just go up here, guys, to keep it on the same screen. I'll do that. Okay, it probably looks a little bit nicer if we multiply above and below by -1. That way I have 1 plus sine x over 1 minus sine x. And then we say y is equal to the square root of 1 plus sine x over 1 minus sine x. And then we should technically write g minus 1 of x is then equal to the square root of 1 plus sine x over 1 minus sine x. Now he does say justifying your answer. What he wants from that is you have to say as domain of g is x is greater or equal to 0, the range of g minus 1 is y is greater or equal to 0. So we need y, we need this has to be greater than or equal to 0. Or I should say maybe g minus 1 of x is greater or equal to 0. Therefore, we only use positive part of root. Okay, so that's just important, guys, that the g minus 1 of x is this, but you can't use the negative part of the root because the range of this function has to be bigger or equal to 0 because the domain of this function is bigger or equal to 0. And then it's a state the domain of g minus 1. Okay, often in these questions when they mix inverse functions with domain and range, the nicest kind of way to do it is to note that the domain of the inverse function is equal to the range of the original function. So I'm going to find, let's do that first, the range of g is, so the range of g, well, we can sketch it first. We can sketch it here, so let's sketch it. Trig arc sine is this one here, and we're going to do x squared minus 1 over x squared plus 1. And this is it, but remember it's only for x is greater or equal to 0. So this is that function. So if we can find the range of this function, we have the domain of the inverse function. And you could sketch that inverse function as well, and you'd see it too. But let's just find, because I think it makes a bit more sense why this is the case. Let's find, well, let's just trace along here and see what's actually happening. So the minimum, if you like, although it's a sharp point, is minus 1.5708. Now you might note, guys, what point is that? Well, that is negative pi over 2. So the range of g is y is greater or equal to negative pi over 2, and it has to be less than, if you remember, guys, from our very first question, or maybe the second question, we said we had a horizontal asymptote, and this is a horizontal asymptote here. It's never going to meet a certain value. If you look at that y value, what's that value that is not going to meet? Well, it's going to be 1.57, whatever pi over 2 is, but it's pi over 2, because that is where the horizontal asymptote is. And if you kind of sub these numbers in here, sorry, not sub these numbers in here, but if you actually think about arcsine, what is the maximum arcsine can be? Well, it's when x is 1. And what's the minimum arcsine can be? Well, it's when x is negative 1. And when x is negative 1, we have negative pi over 2. And this can be negative 1 because x is 0. If x is 0, we're left with arcsine negative 1, which is negative pi over 2. But this actually can't end up being 1, because even if you put in, remember, if you put in a million, you still don't, because of this minus 1, you don't quite get to 1. That's why it doesn't quite get to pi over 2. Okay, so that's the range of g, but it hasn't asked for the range of g, it's asked for the domain of g minus 1. It's only worth 1 mark. The domain is g minus 1 is greater or equal to minus pi over 2 and less than pi over 2. And if you sketch this, well, let's do it. This is only 1 mark. If I sketch this, let's delete all this. Let's zoom back here, and I'm going to sketch the square root of 1 plus sine x over 1 minus sine x. And you'll see here the range of this is, the domain of this is going to be from minus pi over 2, which is this here, to pi over 2. So it's going to start here, and we're not actually going to reach pi over 2 here. There'll be a vertical asymptote for the inverse function. Okay, last question I'll do in the next video.